A beam bridge is the simplest kind of bridge, basically a flat deck resting on supports called piers or abutments. When cars or trains cross, the top of the beam is squeezed while the bottom is stretched, and the supports carry that force down into the ground. Beam bridges work best for short distances, which is why they are so common on highways and small river crossings. Modern beam bridges can be made from steel or pre-stressed concrete and linked together into very long viaducts that stretch for miles. A girder bridge is a stronger, more engineered version of the beam bridge. Instead of a simple slab, it uses large steel or concrete girders, often shaped like an eye or a box, to carry heavier loads over longer gaps. The deck sits on top of these main members, and the weight moves through the girders into the piers below. Girder bridges are widely used for roads, railways, and elevated city routes because they are efficient and practical. Box girder bridges are especially good for curved roads, which is why many freeway ramps use them. A slab bridge is one of the most basic bridge forms, made from a solid concrete slab that spans from one support to another. Instead of using separate beams underneath, the slab itself carries the load and spreads it across its width. This makes slab bridges simple to build and maintain, especially for very short crossings like small streams, drainage channels, or local roads. Because they are low and compact, they often blend into the landscape so well that people cross them without noticing. A truss bridge uses a framework of connected triangles to carry weight. Triangles are important because they keep their shape and spread forces efficiently, letting the bridge stay strong without using a huge amount of material. As traffic moves across the deck, some truss members are squeezed while others are pulled, and together they channel the load into the supports. Truss bridges became famous during the railway age because they could handle heavy trains and be built from many smaller parts. An arch bridge works by curving upward, so the weight of the bridge and the traffic on it is pushed outward and downward into the supports at each end. Stone arch bridges have been used for thousands of years because stone is excellent at handling squeezing forces. Modern arch bridges may use steel or concrete, allowing much longer spans while keeping the same basic idea. Arch bridges are often admired for their beauty, as well as their strength. A tied arch bridge looks like a regular arch bridge, but it has an important difference. The ends of the arch are connected by a strong tie. Usually the deck itself, or a member beneath it. This tie stops the arch from pushing outward too hard on the supports, which makes the bridge useful where the ground is weak or where large foundations would be difficult. Hangers connect the arch to the deck and carry the load. Tied arch bridges are sometimes called bowstring bridges because their shape resembles a drawn bow. A cantilever bridge is built from structures that project outward from supports, a bit like two diving boards reaching toward each other. Each side is anchored firmly, and a central section may connect the extending arms. This design is useful when builders cannot place temporary supports in the middle, such as over deep water or busy shipping channels. The bridge handles weight through a balance of squeezing and pulling forces in its members. The Forth Bridge in Scotland is a famous cantilever bridge. A suspension bridge carries its deck from large main cables draped over tall towers and anchored firmly at both ends. The deck hangs from many vertical suspenders, so the weight of traffic travels into the cables, then to the towers and anchor blocks. This design is ideal for very long spans because the cables can cover huge distances with fewer supports in the water. Suspension bridges are often flexible, allowing them to move in wind and changing temperatures. The Akashi Kaikyo Bridge in Japan has the longest central span of any suspension bridge. A cable-stayed bridge has one or more towers with straight cables running directly from the towers to the deck. Unlike a suspension bridge, it does not rely on huge main cables draped across the whole span. The deck is supported more directly, which often makes cable-stayed bridges efficient for medium to long spans and gives them a striking fan or harp-like appearance. As vehicles cross, the load moves through the deck into the stay cables and down the towers. A rigid frame bridge is built so the deck and the supports are joined together as one stiff frame rather than simply resting on top of columns. Because these parts act together, the bridge can resist bending more effectively and often needs fewer separate bearings or joints. Rigid frame bridges are common for overpasses and medium-length crossings, especially in concrete construction. Their clean shape can make them look simple, but the structure is carefully designed so forces flow smoothly through the frame. Reducing joints can also reduce maintenance, since joints are often where wear begins. A movable bridge is any bridge designed to open so boats can pass through. Instead of staying fixed all the time, Part of the bridge lifts, swings, or rolls away when needed. This allows both road or rail traffic and water traffic to share the same crossing point. Movable bridges are especially useful in busy harbors, rivers, and canals, where tall ships still need access inland. Although they seem old-fashioned, many are highly engineered machines with motors, counterweights, and precise controls. A bascule bridge is a type of movable bridge that opens by lifting one or two leaves upward, much like a giant seesaw. The moving section pivots near one end, and counterweights help balance the load so the bridge can open with less energy. This design is popular in cities and ports because it can open quickly while using relatively compact machinery. When closed, vehicles cross normally. When open, ships pass through the channel below. London Tower Bridge is a well-known example of a bascule bridge. A swing bridge is a movable bridge that turns sideways around a central pivot or pier. When closed, it lines up with the road or railway so traffic can cross. When a boat needs to pass, the bridge rotates, opening one or two channels on either side. Swing bridges were especially popular before modern lifting systems became common, because the mechanism could be straightforward and reliable. They do, however, need space to rotate, and often require a support in the water. A vertical lift bridge is a movable bridge in which the central span rises straight up between tall towers. Cables and counterweights help lift the deck while keeping it level, allowing ships to pass underneath without the bridge swinging or tilting. This type is useful where there is limited room beside the bridge and where a strong, heavy deck is needed for trains or road traffic. The machinery can handle large loads while opening relatively quickly. Some vertical lift bridges raise spans with a system carefully balanced by counterweights. A transporter bridge is one of the rarest bridge types. Instead of carrying traffic across a fixed deck, it has a high overhead structure with a moving gondola hanging below. Cars, people, or even small trucks roll onto the gondola, which then travels across the river while ships pass freely underneath. This design was useful in places needing a crossing but lacking money or space for a full high-level bridge. Very few transporter bridges remain today, which makes them engineering curiosities. A floating bridge, also called a pontoon bridge, rests on the water instead of standing on fixed supports driven into the ground below. Large floating sections support the deck, and anchors or cables hold the bridge in position. This type is useful where water is very deep, the bottom is soft, or building tall piers would be too difficult or expensive. Floating bridges can be temporary for military use or permanent for major roads. Some of the world's longest floating bridges are in Washington state, where deep lakes make ordinary bridge foundations hard to build. A stress ribbon bridge is a very slender bridge whose deck follows a gentle hanging curve, almost like a tight ribbon draped between supports. It works somewhat like a suspension bridge, but the deck itself helps carry the tension forces, often with steel cables embedded in concrete. Because the structure is thin and elegant, stress ribbon bridges are usually used for pedestrians rather than heavy traffic. They can blend beautifully into parks and natural settings. These bridges often feel surprisingly stable even though they look delicate, because their curved shape is doing most of the work. A covered bridge is not a separate structural system by itself, but an important historic bridge category. It usually contains a timber truss inside a roofed and sided enclosure. The covering protects the wooden structure from rain, snow, and sunlight, greatly slowing decay and helping the bridge last much longer. That is why many early wooden bridges were built with walls and roofs, especially in North America and Europe. Covered bridges are often linked with rural scenery, but they were a practical engineering solution. Some have survived for more than a century, mainly because the roof kept the timber dry. A viaduct is a long bridge made of many shorter spans, used to carry a road or railway across a valley, floodplain, city streets, or other obstacles. Instead of one giant leap, a viaduct repeats the same structural idea over and over, using arches, girders, or other span types. This makes it a category based on purpose and form rather than one single structural method. Viaducts are common in rail networks and elevated highways because they can cover long distances efficiently.